राइट, सो सेटल्ड। आप लोगों में से कुछ फ्लोटिंग पॉपुलेशन है क्या? मतलब संडे वनडे को नहीं आते हैं? ऐसा भी है सर, संडे को कुछ भी हो हम पढ़ेंगे नहीं, ऑफ है। संडे ब्यूरोक्रेट्स को ऑफ होता है, हम ब्यूरोक्रेट बनने वाले हैं, तो हम संडे तो ऐसे ही ऑफ लेने वाले हैं। हाँ, कितने लोग हैं ऐसे? बिकॉज दे हैव सम फेसेस दैट आई डोंट गेट टू सी ऑन संडे, है ना? तो चलो ठीक है, या कोई और क्लास था ये सोच के आ गए? हाँ सर, हमें पता नहीं था ज्योग्राफी है, वरना नहीं आते। ज्योग्राफी समझ में आ रहा है पक्का? ये इस सब्जेक्ट के साथ ना एक बहुत बड़ा प्रॉब्लम है, या तो ये अच्छा लगता है या बुरा, ये बीच का किसी को भी नहीं लगता है। सर ठीक है टाइप का ना, कोई भी स्टूडेंट इसके साथ होता नहीं है। या तो ठीक है, अच्छा है, या फिर नहीं समझ में आ रहा है यार, वो सब्जेक्ट ही समझ में नहीं आता है, अजीब सा है। So how many of you still feel अजीब सा है? अच्छा, अभी तो सर आपकी बात ही नहीं सुन रहे, क्योंकि टॉपिक तो आपने स्टार्ट किया नहीं। आप जब तक टॉपिक पे आओगे नहीं तब तक बात सुन के फायदा क्या है ना? हाउ मेनी ऑफ यू स्टिल फील ज्योग्राफी थोड़ा डिफिकल्ट है, कुछ चीजें नहीं समझ में आती हैं? ऑनेस्ट आंसर, ऑनेस्ट आंसर। आई नीड दो ऑनेस्ट आंसर, क्योंकि उसके बिना तो काम चलेगा नहीं ना। हम्म, बस इतना ही है, और वो सारे आगे ही बैठे हैं, पीछे वाले तो सबको सर यहाँ तो सब कुछ क्लियर है। पक्का? बस इतना ही है? तो आप लोग के लिए स्पेशल ट्यूशन चालू करें? ये जो 4 5 6 थे, होता था ना स्कूल में, वी यूज्ड टू हैव स्पेशल ट्यूशन। हाँ, आफ्टर क्लास। सॉरी, नहीं नहीं, पैसा नहीं लेंगे उसके लिए, डोंट वरी। ऐसे ही आप लोग से बहुत पैसा ले लिया है, तो अभी और क्या पैसा मांगेंगे? हाँ जी। हाँ, अच्छा, टाइम 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 हो गया है सर? टाइम क्या है, कितने बजे आना है? अच्छा, ये तो सीरियस ही हो गया सर। आप लोग, चलो ठीक है। नहीं, इफ यू रियली नीड, सम ऑफ यू रियली नीड, बिकॉज अर्लियर आई डिड, मे बी अभी इधर कुछ टाइम से तो जरूरत नहीं पड़ता था, बट if you really need, some of you feel कि कुछ doubt है, that's why I stay here. If you want you can tell me, sir ये 2 3 topics है, we didn't get it, and I can maybe stretch half an hour more for the ones who want to stay back and repeat the topics. That's perfectly fine, हो सकता है नहीं समझ में आया हो, you know. So if you really think कि कुछ ऐसा topics है, all of you, this is for all of you, and starting from class 1, if you have a list of topics which you feel you did not get well, you can probably share it with sir, right? And maybe on some day I'll have to ask the office also on which days these halls are not having another class after my class, so we can fix up another class for you, maybe if you want, maybe कोई एक extra, whatever you call it, doubt solving class or whatever, ठीक है? So that is something that you as a class have to decide whether you want. आज सुबह ऐसे ही मेरे मूड में आया, देखें यार ये क्या है, मतलब कहाँ तक समझ में आ रहा है, बिकॉज तो रेस्ट ऑफ यू आर ओके, मतलब ब्रॉडली समझ में आ रहा है ज्योग्राफी? पक्का? यस सर। ओके, चलो ठीक है, तो आपकी बात पे विश्वास कर लेते हैं। दो, मेरा ज्यादा मन होता नहीं आप लोग की बात पे विश्वास करने का, क्योंकि अब सर है सामने तो क्या बोलेंगे, बोल दो, कौन सा आके कॉपी चेक करने वाले हैं। चलो, आई एम अज्यूमिंग कि समझ में आता है, वेरी गुड। और जो नहीं आता, आई एम अज्यूमिंग दैट यू वुड शेयर विद मी एंड सर, राइट, एंड वी कैन फिक्स अप सम टाइम एंड वी कैन डू इट, ठीक है? तो अभी आगे बढ़े। ओके, सो व्हाट टॉपिक वर वी सपोज टू डू? हाँ, प्रेसिपिटेशन। ओके, द वंस हु आर न्यू टुडे, आप लोगों को भी पता है ना प्रेसिपिटेशन तक पहुंच चुके हैं? एक टॉपिक होता है ज्योग्राफी में प्रेसिपिटेशन नाम का, सो वी आर अबाउट टू डू दैट, ठीक है? एंड प्रेसिपिटेशन हैपेंस बिकॉज cloud formation takes place, and cloud formation happens because humidity is there, ठीक है? तो Start? Okay, good. So let us start with forms of precipitation. Different forms we have written in the last class. Forms of precipitation हमने लिखा है, we haven't discussed, है ना? So which were the different forms of precipitation that we have written? Sorry? हाँ नहीं, अच्छा liquid and solid, और उसका बाकी कौन सा है सब? So one is rain, then you had snow, then you had hail, and you had sleet. ये चार forms हमने देखे हैं. So we have to see how do we get these four forms of precipitation happening. Okay, now by the way, if I ask you before you go there, before you come to this topic, precipitation simple means what? Simple English meaning of precipitation. English, not geography. Settling down. है ना? Settling down of anything is called as precipitation. So for the ones who want a English meaning of this word, that is settling down of things which are suspended. Anything which is suspended, when it settles down, we call it as precipitation, right? So when you talk of atmospheric precipitation, what all things in the atmosphere can precipitate? Right? Gases cannot, right? Maybe dust particle can, right? So dust particle precipitation can happen. But when we generally say precipitation in the atmosphere, we are talking of the water vapor precipitation. Okay, the water in the atmosphere getting precipitated. But will the water in the gaseous form precipitate? No, gases do not precipitate in general, right? Until unless there is too much of density variation. So we don't talk of that. So what form of water in the atmosphere will precipitate? It is the one which is in liquid form, at least liquid or solid state. So the first thing that we have to learn is how do these water vapor turn into this solid or liquid form? Now we have already seen that the clouds themselves are nothing but small liquid droplets, है ना? I hope all of us remember from what we have done till now that cloud themselves is nothing but liquid droplet, छोटा size का liquid droplet है which is suspended in the air. I hope this is the definition of cloud that you already have in your copy. यही लिखा हुआ है ना? Can you just cross check all of you that cloud is the small liquid droplet suspended in air. Now why is it suspended? Because it is relatively very small and hence the weight is not enough against the strong winds to bring it down. ठीक है? The way you might have seen feather. Feather देखा है कभी हवा में उड़ता हुआ? वो क्या बोलते हैं उसे अब? The पंख है ना? छोटा या रुई का टुकड़ा या you know. So you might have seen these things floating in the air. Why do they float and why don't they fall down? Because the wind is strong enough to keep them floating. The same ways cloud are also kept afloat by the winds. Okay, so in the cloud there are small droplets but they are not falling down. By the way, how did those droplets form in the cloud? वो बने कैसे थे? Because of condensation. And what caused that? What were the preconditions for condensation? दो precondition था. One was dew point and second was some hygroscopic particle. And what type of hygroscopic particle did we consider for cloud formation? Big or small? Small. So around small hygroscopic particles we get small droplets form and those small droplets come together and stay together and stay afloat in the air called as cloud. तो छोटा droplet तो बन गया. But for precipitation, gravity has to be able, no, you can't increase the gravity. Gravity has to be able to pull it down and for that the weight of the object should be, or those droplets should be high, which means you now need bigger droplets for them to precipitate. So how will, from smaller cloud droplets, how do we get those bigger droplets? वो कैसा बनेगा? We have to understand this process. Is this understood? So precipitation mein, when we talk of forms of precipitation, we have to understand how small droplets in the cloud turn into bigger droplets so as to become raindrops and fall down. Okay. So the first question is, why don't the small droplets in the cloud themselves join together and become big? वो क्यों नहीं हो जाते अपने आप? In cloud you have lot of droplets and they are all small. Why don't they themselves join and become big. Right? This is one thing that we have to ask to ourselves. That ऐसा क्यों नहीं होता है? तो क्लाउड में तो बहुत सारा small droplets है ना. They can just join themselves amongst themselves and become bigger and fall down. But that doesn't happen in cloud. Right? For the smaller droplets to become bigger droplet, you need another condensation nuclei or a hygroscopic particle, and this time you need a relatively bigger hygroscopic particle. Okay, so when in those clouds there are relatively bigger hygroscopic particle or condensation nuclei, then around those condensation nuclei, small droplets join. Right? Small droplets do not join to each other. They join around or they stick to a bigger condensation nuclei. So we have to understand how do those bigger condensation nuclei reach in the upper atmosphere, वो समझना है. But when do they join? When do the small droplets in the cloud join? They join when there is a presence of bigger hygroscopic particles in the cloud. Is that okay? And once they are there, then around those around those bigger hygroscopic particles, small droplets will come and join, and they will make a bigger droplet. And once that bigger droplet is formed, then it will fall down. So how will you make the clouds turn into rain? You have to make the presence of bigger hygroscopic particles. And what are hygroscopic particles? They are nothing but dust particles. And where are bigger dust particles found? On the surface of the earth. So how will you ensure that those bigger surface means close to the surface of the earth? So how will you ensure that those bigger droplets, those bigger hygroscopic particles reach the upper atmosphere in the cloud? Same process, है ना? You have to ensure that wind is rising. When the wind will be rising, it will be able to carry the dust particles from below. So for precipitation to happen, the most fundamental condition required is rising of air, which is able to carry with it bigger hygroscopic particles or dust particles. Once they reach in the cloud, around those bigger particles, other droplets will come and attach, and they will make a bigger particle, bigger droplet, and then those bigger droplets will form. Right? So we call it as, there's a theory behind it. When you do, the ones who have geography as an option, there they will do the theory called as the condensation coalescence collision theory. Okay, but we don't have to do that. We just have to understand the essence of that theory. The essence is smaller droplets join around hygroscopic particle, make bigger droplets and fall down. That's it. That's the essence. ठीक है, उसके आगे हमें उस theory में नहीं घुसना है. Is that all right? ठीक है. So this is the basic logic of how rains will happen. So the moment you have cloud, will you get rain? Just cloud, can they cause rain? No. This is the most fundamental thing here. What is required for rain to happen? Along with cloud, you need something more. What? Rising air. Once you have rising air, then only the rising air will ensure that it is carrying dust particle, provided dust particles are there in the lower region. Right? Once it carries the dust particles up, then those dust particles will act as the trigger, and around those triggers, that is what you call as condensation nuclei, other particles will come, attach and this thing. But why do they attach around dust particle and not among themselves? ऐसा क्यों करते हैं? There's the logic behind this pretty much of physics. Surface tension of those droplets. ठीक है? So small droplets having same surface tensions do not collide and join. That's a basic rule in, right? For colliding and joining, they need something which has a different surface tension with it. But do you have to remember this surface tension? No. What is this? Why is this happening? I generally give this example. For example, let us say so many of you are there and all of you are almost at the same level. So do you tend to become friends very easily with each other? Yes and no. Both the answers are there. Right? Sometimes yes, sometimes. Why no? वो no का reason क्या है? Because आप सबका अपना अपना ego है. Personal ego. Right? So your personal ego is similar to water droplet का surface tension. ठीक है? जब सबका ego equal है, तो कोई भी किसी से जल्दी दोस्ती नहीं करता है. वो कहता है जब वो नहीं बोल रहा तो why should I? है ना? But let us say I drop between you 3 or 4 mains people who have written interview. Suppose, or given the interview, मतलब written mains and given interview, वो आके बैठ गया. आपको पता है साथ वाला ने इंटरव्यू दिया है, तो क्या करोगे? धीरे धीरे यार क्या क्या किया था, है ना, कैसा तैयारी किया, हाउ डिड यू रीच, आप यू विल ब्रेक द वाटर योर सेल्फ, इजंट इट, और ब्रेक द आइस योर सेल्फ एज दे, नॉट ब्रेक द वाटर, ब्रेक द आइस, ब्रेक द वाटर कुछ और होता है, सो यू ब्रेक द आइस योर सेल्फ, इजंट इट, राइट? सो आई होप यू अंडरस्टैंड व्हाई डज दैट हैपन, क्यों किया आपने उससे दोस्ती? आपको पता यार इसके सामने ईगो दिखा के फायदा नहीं है, ये थोड़ा ऊपर है ना, लेवल ऊपर है, अपने दिमाग में अपने आप आ जाता है ना, वो सरफेस टेंशन वैसा ही वर्क करता है, ठीक है? सो अ ड्रॉपलेट विच इज बिगर वुड हैव अ डिफरेंट सरफेस टेंशन, इट इज इजी फॉर इट टू अट्रैक्ट अदर smaller droplets, but small droplet themselves are not able to attract another small droplet, right? In, if I have to tell you in very simple language, it is something like this, right? So what is it? Small droplets are not, and that's exactly why in cloud themselves droplets do not form, ठीक है? क्लाउड कितना भी होगा तब तक बारिश नहीं होगा जब तक rising air is not there. Do we get? So you have understood two things here, one how droplets are formed, and second what are the primary condition for droplets to form, ठीक है? The primary condition for precipitation to happen is rising air. Is this okay? ठीक है? So once we understand the primary condition for precipitation to happen is rising air, how many types of or in how many ways can you have air rising? वो भी अभी तक पढ़ा है आपने थोड़ा? नहीं पढ़ा है, I don't know. Let us see. So if I say in how many ways have you understood rising air? कितना जगह पे आपने देखा है अभी तक rising air? I think हमने देख लिया है. For example, high pressure or low pressure? Low pressure. So one is low pressure, and in low pressure can be created thermally and mechanically, ठीक है? So when you have thermal low pressure or you have mechanical low pressure, in both the cases it is something like convection, right? So one type of precipitation that you get is due to convections, convectional precipitation बोलते हैं उसको, ठीक है? Wherever you have a low pressure on the surface and wind is rising, there you get convectional precipitation. Please do write, right? So processes causing precipitation, and then we'll come back to this forms, ठीक है? So processes causing precipitation, processes causing precipitation, ठीक है? So one is the low pressure, which gives you, which is due to thermal or mechanical reason, and the air tends to rise in this, ठीक है? So where do you get convection? Something like this, ये है convection. This is your convection diagram. If you want, you can draw a simple convection diagram also, ठीक है? So in convection, low pressure will be there, wind will rise. As the wind will rise, it will tend to create its own clouds many times. जैसे हमने, cloud can be created by this process, and after that, further precipitation can also be caused due to this. So dust particles going up and precipitation happening. Is this okay? So this is convectional precipitation. We call it as convectional precipitation. So one process of precipitation is convectional precipitation. The other one, दूसरा कौन सा पढ़ा है आपने? Where winds or air tends to rise? हाँ? On the slopes of mountain, where the air tends to go up. कौन सा wind पढ़ा था हमने? I need the name of those winds. Orographic और valley wind, और वो पढ़ा था ना आपने, valley और mountain. तो कौन सा wind में air goes up? Valley, right? In the valley wind, the wind tends to rise up. ठीक है? So valley winds will also give you orographic or valley winds. They will also give you cloud and precipitation. ठीक है? So what does that look like? ऐसा. We call it as orographic precipitation. ठीक है? So second way, orographic, where the wind is rising, going into the clouds and causing the precipitation. Right? In all of them, the common thing that is happening is carrying of the dust particle upwards, and making the humidity higher and all that. ठीक है? Then the third one, and the third one कौन सा है बताइए? हाँ जी, cyclonic. Do you remember cyclonic winds? Spiraling inward, low pressure, spiraling inward and rising vertical. ठीक है? So the third one we call as cyclonic wind, and there are two types of cyclonic winds. One is this one. This is your spiraling one, right? Convergence of air again, and spiral, convergence and spiral. So this we call as tropical cyclonic. Tropical cyclonic. Okay. So tropical cyclonic, and the third one, the fourth one is again a cyclonic one, but this is temperate cyclonic. Temperate cyclonic, also known as frontal precipitation. Frontal precipitation. Okay, so in cyclonic you have two types, tropical cyclonic and frontal cyclonic. Okay, so how many processes of precipitation did we understand? One, convectional, second, orographic, and third, cyclonic. And within cyclonic you have two types, the frontal cyclonic or the temperate cyclonic and the tropical cyclonic. Okay, so when we do tropical cyclones and temperate cyclones, there you will understand how and why the wind is rising. वो हम वहाँ करेंगे. ठीक है, orographic and convectional you understand. All right. So once we understand the processes causing precipitation, processes समझ में आ गया, and how many or which processes ultimately give you precipitation? These. And if you want, you can write at the end of all this. In all of this, the common element is rising air carrying the, in all of these, the common phenomena, in all of these, the common phenomena is rising air carrying relatively bigger dust particles within bracket hygroscopic particles, carrying bigger dust particles within bracket hygroscopic particles toward the clouds, towards the clouds in the upper atmosphere, where different forms of precipitation take shape around these hygroscopic particles. Take shape around these hygroscopic particles. Okay, good. So now let us come to different forms of precipitation. Now put that thing. So processes you understand. Now again come back to form. In the meantime, online people, you have also said, responded to my question, sir, हमको भी same class चाहिए. So whenever we do that class, don't worry, है ना, वो मिलेगा, सबको मिलेगा, मतलब ऐसा नहीं कि आपका वीडियो ऑफ कर देंगे तब, you know, we'll do it a cumulative class for all of you, offline, online. Sir, just figure out with them, sir. Just figure out with the online and offline people. No, that's perfectly fine. When we can fix a class for them, and let's try. We'll do maybe what we'll do is on the day when they have a class and this classroom is empty after the break, so we can spend 1 hour whatever they want, right? Okay, we'll do that. Don't worry. ऐसा बुरा मत feel करो sir. हमको भी चाहिए ऐसा. Okay. So good. Come back. So let's come back to the forms of precipitation. So first one we write rain. Rain. Yeah. For rains, for precipitation, it okay. No, so when you are saying, देखो आप खुद ही बोल रहे हो दो चीजें ना. For raining, the wind has to rise 2 times. One for cloud formation and second for rain. आपने खुद ही बोल दिया. रेन के लिए तो एक ही बार गया ना. फर्स्ट बार किसके लिए गया? क्लाउड के लिए. So for rain you need the winds to rise one, and one time they have to rise for cloud formation. ठीक है? And it is pretty much possible that in one go itself it rises, it forms the cloud, and then from the same cloud it causes precipitation. वो भी हो सकता है. ठीक है? It is able to carry so much dust particle and moisture that when it rises, it condenses, it creates cloud, and from that cloud it also creates rain, depending on if bigger particles are available. तो दोनों चीज साथ भी तो हो सकती है. ठीक है? और many times it can only be one, that only the clouds have formed, but rains have not happened. So in that case you need some more, right? Is this okay? Have you people heard this term artificial rainfall? है ना, cloud seeding, artificial rainfall. उसमें क्या करते हैं आप? What do we do? There is moisture in the air, but rain is not happening. So what do? We artificially go in the upper atmosphere and release hygroscopic particles such as silver iodide. And that is one of the most commonly used hygroscopic particle. So we just go up in the atmosphere and we release there from aeroplanes or balloons or whatever. We release hygroscopic particle in the upper atmosphere. So those hygroscopic particle might accumulate the water droplet from surrounding, and then it might cause precipitation. तो इसको हम cloud seeding भी बोलते हैं. That you are seeding within the cloud or you are seeding for the cloud. Is this okay? So that's how you try to create rain, but it's not possible that every time you try to do it, it happens. Why? Because many times in the upper atmosphere, the winds are so strong that whatever hygroscopic particles you have, put there, they might be blown away, right? So if the conditions are suitable, then rain might happen. If the conditions are not suitable, then even if you're doing cloud seeding or artificial precipitation, you're trying for that, still it might not happen. Is that okay? Okay. So we'll write that part later, but first let us understand this. Okay. So let us write. I think the subheading you have written, rain. So under that write down that when relatively bigger hygroscopic particles reach the cloud by the processes given above. Reach the clouds by the processes given above. The smaller cloud droplets collide and combine around these forming bigger raindrops, which now under gravity which now under gravity tend to fall to the ground, tend to fall to the ground in the form of rainfalls. Fall to the ground in the form of rainfall. Listen. For this phenomena to happen, the cloud themselves should be above freezing temperature, should be in a above freezing temperature region, above freezing temperature region, so that they remain liquid. Above freezing temperature region, so that above freezing temperature region, so that the droplets remain liquid. ठीक है, droplets remain liquid. I have not given you 0 degree temperature, but I have given you freezing temperature. Does the freezing temperature remain constant at all pressure? No, right? As you go higher, the pressure changes and the freezing temperature will also change. So at every altitude, freezing temperature tends to change, right? So if the cloud is above freezing temperature, it will remain liquid, and the rain will also be liquid, because rain is in the liquid form. If the cloud is in a frozen form, we'll see what will happen. Abhi dekhte hain. Is this okay? So where all will you get clouds which are in a above freezing temperature region? For example, generally the clouds in the equatorial tropical region, they might be above freezing, है ना? At the same altitude, if you see, because the surface temperature in the equatorial tropical region is high, lapse rate तो fix ही है 1.65. So generally the clouds in the tropical and equatorial region, right? Then when you go to temperate region, which season should you expect the cloud to be above freezing temperature? Generally in the summer, बोल सकते हैं? So I want you to write these places also. For example, clouds up to a certain height, in the equatorial tropical region, and in the temperate region, during summers, are above freezing temperature, ठीक है? And hence they give you, and hence we mostly get rains from them. So in these regions you will not get snowfall. Why? Because the cloud itself is not in a freezing zone. Is this okay? Right? Now let us come to the second one after this. So the second one is sleet. Okay, sleet. अच्छा एक काम करो, sleet से पहले let us do snow, so that you understand snow, and then we come to. So write snow. What happens in snow? Okay. By the way, what is the difference between ice and snow? If I ask you, ice और snow, मुझे practical difference चाहिए जो आपने देखा है. मुझे book का definition मत देना. मैंने फिर से बोला ना, मुझे practical example चाहिए, book का definition. आई, वाह, क्या बात है सर. आइस फेंक के मारो तो लगता है, स्नो फेंक के मारोगे तो लगेगा नहीं. वेरी गुड एग्जाम्पल, आई वुड से वेरी गुड एग्जाम्पल. हाँ, आइस इज ट्रांसपेरेंट, स्नो इज नॉट. चलो वो भी एक चीज है, बट बहुत ही अच्छा आपने बोला. आई रियली लाइक्ड इट. सर आइस से मत मारना, जब भी मारना स्नो से मारना. दैट विल स्टिल नॉट हर्ट. वेरी गुड. वाई डजंट इट हर्ट नाउ? वाई डजंट इट हर्ट? प्लीज लिसन. द आंसर इज देयर. Yes, I'll come to you. Don't worry. Yes. Why doesn't it hurt? Because snow is made up of lighter particle. मतलब उसके अंदर एक ही आइस के जैसा वो एक ब्लॉक होता है या बहुत सारा चीज होता है? Right. Very good. Perfectly fine. So in snow you have very small, distinct particles. Every snow flake is a distinct particle in itself. So when you take snow like this, you are not taking one snow or one flake of snow, right? You are taking a bunch of snow. That bunch is made up of lot of snow flakes. ठीक है, जबकि आप आइस उठाते हैं तो एक टुकड़ा उठा लेते हैं और पूरा एक हार्ड शेप्ड थिंग है, राइट? एंड इट कैन बी एज हार्ड दैट इफ यू हिट इट रियली हार्ड, या यू नो बहुत सारा मूवीज में दिखाते हैं, वो आइस का चक्कू बना के मार देते हैं और फिर चक्कू वहीं छोड़ देते हैं, उनको पता है 10-15 मिनट में मेल्ट हो जाएगा, है ना? एक मूवी था सुष्मिता सेन का, बहुत पुराना मूवी है, तो उसके अंदर वो आइस से, मतलब आइडिया नहीं है ये आप लोग के लिए, ठीक है? ऐसा नहीं कि कल से सबके सब अपने फ्रिज में एक एक आइस चक्कू जमा के रखा हुआ है, कोई भी आया दिखा के पास नहीं आना, ओके? 15 मिनट में कोई नामो निशान भी नहीं बचेगा, ओके? बट डू यू अंडरस्टैंड? सो आइस इज प्रीटी स्ट्रॉन्ग एंड ऑल ऑफ यू हैव सीन ऑल्सो, आपका फ्रिज के अंदर, फ्रिज में देखा है आइस, तो देखा ही है ऑब्वियसली, स्नो देखा है फ्रिज में, है ना? वेरी गुड, याद आ रहा है ना? गर्मी वर्मी में जाते थे, ऐसा ऐसा करके कुछ फिंगर से निकाल के मुंह पे लगा लेते थे, खा भी जाते थे, है ना? रिमेंबर? सो दैट इज स्नो थिंग, ओके? सो इन योर रेफ्रिजरेटर यू हैव बोथ ice and, so ice is hard, snow is flaky, it is like your cornflakes. तो जैसा कॉर्नफ्लेक बड़ा होता है, आइस फ्लेक छोटा होता है, ठीक है? और कैसा दिखता है? व्हाट डज इट लुक लाइक? ऐसा, ठीक है? ऑल ऑफ दीज आर आइस फ्लेक्स, सॉरी स्नोफ्लेक्स, राइट? So this is how snowflakes, when you zoom a snowflake and take an image, it will look like this, right? And it always grows into a hexagonal shape geometrically, right? So in the center of it, you will always have some particle. Around that, it would accumulate and gradually grow and take shape, right? And because it is wide and thin, therefore it is able to float in the air. So it doesn't, snowfall, the ones who have seen amongst you would recall that snowfall doesn't happen as heavily as rainfall. Snow बहुत gradually fall करता है. Why? Because it is flat. So it tends to float in the air and then gradually come down. Unlike rain, rain will fall like, you know, if it is heavy rainfall, it might fall very fast also. Is that okay? Do we understand this? Alright, समझ में? So what is snow? Something like this. And how does it form? The difference is snow formation happens directly from those small droplets. ठीक है? So in snow formation, the formation happens directly from this, around those hygroscopic particle. Let us say here you have a hygroscopic particle. So around this, small droplets will go on coming and freezing instantly. So they come and freeze. Why? Because the cloud is in a freezing temperature region, right? So when the cloud itself is in a freezing temperature region, it will directly freeze into snow. So when this direct freezing takes place, you call it as snow. When it turns into a water droplet and then freeze, like in your refrigerator. आपका रेफ्रिजरेटर में आइस कब जमता है? When you put water in your refrigerator. And when do you get those flaky things? From the humidity within the refrigerator in the air. है ना? उसका वजह से उसका पूरा बॉडी के ऊपर आपने देखा होगा small, you know, those flaky things accumulate. There you have not put any water. Why did it accumulate? Because in the air there was water droplet and they directly froze on the surface. Direct freezing above. So it's not turning into a water droplet first and then freezing like the ice. So this is the difference between ice and snow. Snow freezes directly, ice freezes from water. First it will be water and then it will freeze into ice. Okay? So when it is freezing from water, it takes that hard shape. And when it is directly freezing around a particle, it will just go on accumulating like, you know, small droplets, and then the whole thing will become a bigger thing. Do we get? Now for this to happen, कैसा temperature चाहिए? You need the cloud to be in a sub-freezing zone. The cloud itself should be in a sub-freezing zone. So which region will the clouds be in the sub-freezing zone? कहाँ पे वो sub-freezing zone में होगा? Polar region. The cloud itself will be in the sub-freezing zone because the whole region is frozen. In the temperate region, during winter season, कह सकते हैं ना, winter के अंदर cloud temperate region will be cold, so the cloud will also be in the cold region. Or in the tropical region, when you go to very high altitude such as mountain tops, for example in India, when you go to mountain top, है ना? For example, if you go to Manali or if you go to top of some snow mountains and all, there you will find snow. Why? Because the air is cold and sub-freezing. So whatever cloud is there in that region, from them, those clouds, you will directly get formation of snow. वहां rain नहीं बनेगा. Do we get it? Is this broadly understood? ठीक है? So should we write that snow thing? Please do. Snow forms in the snow forms in hexagonal shapes. Snow forms in hexagonal shape as very small flakes. Very small flakes. F-L-A-K-E-S. Flakes. What is a flake? A flat, thin, any flat, thin shaped thing. Like the cornflake. अगर आप चाहो तो अपना example के लिए लिख सकते हो so that you understand. Right? So you have cornflake, or when you see your dandruff come out, that also comes out in the shape of flakes. देखा है ना? Dandruff होता होगा कुछों को, है ना? तो आता है ना flake के जैसा पतला पतला. So that is what you call as flake. Is that okay? So clear? Understand? Right? So the snow. Can you read? आप read कर सकते हैं? You. Very small flakes which are flat and very lightweight. Which are flat and very lightweight and formed due to direct freezing. Formed due to direct freezing of cloud droplets. Formed due to direct freezing of cloud droplets around bigger hygroscopic particles. Around bigger hygroscopic particles into snowflakes. Into snowflakes. ठीक है? Full stop. Hence for this we need the clouds to be in a sub-freezing temperature zone. Sub-freezing temperature zone. Such as clouds in A, B, C, D. You write like this. Such as clouds in A, polar region. Winter season in temperate region. And lastly, high altitude mountainous regions. High altitude mountainous regions in tropical zones. ठीक है? So this is how you get snowflakes or snowfall. Perfect. Good. Now the third one, sleet. So you understand rain, you understand snow. Now come to sleet. S-L-E-E-T. The third form of precipitation. Sleet, the third form of precipitation. Okay. So how does sleet form? Now sleet formation takes place from rain. See, this is another set of images that you see for snowflakes. Can you see? Right? So these are all snow images, and when you see a snow image also from very close, it is transparent only, as you can see here. Okay, but it's only that the particles are so small that when you accumulate lot of them, they start giving you that, what you call as opaque type of feel. Right? It is something like if you have very small balls which are transparent, glass balls, and when you put lot of those small glass balls in a place, the whole place might look opaque. तो वैसा ही दिखता है वो. Is that okay? Very good. Now let us come to sleet, as I said. So what is sleet, by the way? How many of you have seen sleet? देखा है ऐसा कुछ on the surface, right? So you will see it will feel like something, you know, some rough kind of this thing. So it will not be very big frozen balls. They are like small raindrops which are frozen. So what is sleet? We write them. Sleet is frozen raindrops. Simply said, sleet is simply said frozen raindrops. Frozen raindrops. And are formed, frozen raindrops, and are formed when rain falls from the cloud. Rains fall from the cloud, which means cloud is in what region? Sub-zero or above, sorry, sub-freezing or above freezing? Above freezing. So for sleet, this is the condition. The cloud has to be above freezing, right? So when the rain drop from the cloud and while falling, please go on writing, and while falling, rain fall from the cloud and while falling, they pass through a freezing zone. While falling, they pass through a freezing zone below the clouds. Just wait and just go on understanding, write, draw. I'll come to your doubt in the end. Okay, just give me some time. You will understand yourself. The drawing will explain. So as you can see, here you have cloud. दिख रहा है board पे? And then from the cloud, what is dropping? What region is the cloud in? Written next to it. Above freezing. And then from the cloud, what is falling? The rain. As the rain continues to fall, what region does it come into? The freezing zone. The moment it will come into freezing zone, the raindrops will turn into what? Snow or ice? Ice. They start turning into ice drops. Okay? So they will turn into small ice drops. And then these ice drops will fall down. Do we get it? So as the ice drops fall, इसको हम क्या बोलेंगे? This is sleet. That's it. Okay? So पहले इतना बना लीजिए. All right. Now, hence, do we, for formation of sleet, where should the clouds be? Should they be in polar region? Will I get sleet in polar region? Will I get sleet in cold temperate region? Again, no. Will I get sleet in the high mountains? No. Where will you get it? You will get it in equatorial tropical region or warm periods or warm season in temperate region. But then the question could be, sir, where does this freezing zone come into play? ये किधर से आ गया? Right? So just imagine. Suppose you have plains and let us say on side of plain you have a mountain. And on the top of the mountain you have snow. यहाँ पे ये snow है. Any wind in contact with this surface becomes frozen. And if the wind tends to flow like this, driven by the upper atmospheric winds, then this cold wind can come into that region. Once it comes into that region, because it is freezing, it can create the sleet type of condition. आ रहा है समझ में? So these are caused due to some cold wind blowing in the upper atmosphere, which could be due to one, jet stream. Second, they can come from mountain surfaces. Right? So या तो jet stream cold wind ले आए, या फिर mountain surfaces are, you know, making cold winds go straight in the upper atmosphere or these regions. Right? So there has to be some set of conditions which will give you this. It will not happen in general. That's why you don't get sleet so often. Sleet will happen only in very rare cases. Most of you might have seen sleet, but it doesn't happen every time it rains. It happens maybe once in years that you get to see sleet. You get to see hail more often than this, many times. ठीक है, तो अभी hail पे भी आते हैं. Is this okay? Clear? Do we understand? So we have to write. अभी लिखना है. What is the last line that I dictate? You read. Perfect. Right. Continue to write below the cloud. Then write down the freezing zone. The freezing zone below the cloud. The freezing zone below the cloud is created. Freezing zone below the cloud is created due to either cold mountain winds blowing in the middle atmosphere. Cold mountain winds. I'm not saying breeze here. Cold mountain winds blowing in the middle atmosphere carried by jet streams to or cold jet streams themselves bringing down colder air. Into the middle atmosphere. Alright? So whichever way you get cold air below this, you will experience this kind of sleet formation. Right? And sleet formation is not a phenomena of very cold regions. Right? It's not because in very cold region you will not get this. You might get directly snowfall. Alright? आगे बढ़े. So now the fourth one. चौथा कौन सा है? Fourth, hail. Let us come to hail. Alright. So how does hail form? You have some doubt here? कोई doubt है आपको? पक्का? Okay. So coming back to hail formation. Hail formation happens pretty much like sleet. There is just one additional condition here. ठीक है? So should I use the same diagram? And चलो मैं copy paste कर लेता हूं. आप देखो क्या करना है. Alright. So you have something like this is your sleet condition. Clear है? यही बनाया था ना sleet में आपने. I'm just rubbing the sleet droplets out of this image. ठीक है ऐसा. And adding the next condition. So first of all, the condition comes up to that sleet thing where there is a sub-freezing zone and there the sleet formation takes place. But the additional condition here is that there is also some kind of convection taking place in the atmosphere for hail to form. So hail formation के लिए आपको यहाँ एक convection भी चाहिए ऐसा, right? Some convection from the surface, mechanical or whatever, right? Orographic, mechanical, whatever. You need some rising air. What will this rising air do to the sleet? They might carry the sleet back into the clouds. Do you understand? They were falling due to gravity, but if there is a rising convection, it might be able to overcome the gravity and it might carry all the frozen droplets back into the cloud. When the droplets go back, those frozen droplets go back into the cloud, something like this, ऐसा, ठीक है? Around those droplets, more water tends to accumulate, right? So around that droplet, more water will accumulate, something like this, and this way that whole thing will become bigger in size. Imaginable? So sleet is going back into the cloud, more water is accumulating around it, and then the whole thing becomes bigger. As it becomes bigger, it will tend to again fall down. Come to which region? Freezing region. What will happen to the water around the sleet? It will refreeze. Do we get it? So what will happen? Refreeze. When it refreezes, what will happen to the shape of that whole sleet thing? It will become bigger. So how does sleet, and when it becomes bigger after refreezing, that's what you call as hail. Okay, do we understand? So for sleet formation you need one time refreezing, which means the whole thing comes from as raindrop and freezes. For hail formation you need multiple refreezing, right? Single freezing में नहीं बनता है वो. In single freezing, if no convection, it forms as sleet, and if it goes back, accumulates more water, comes back, again freezes, तो अभी नीचे आकर के it might become slightly more bigger. And let us say the convection does not allow even this to fall down, because as you come down the convection will be stronger, so it might carry it back again. The more number of times it will go back, the bigger it will become. Imaginable? Yes or no? The more number of time it goes back, the bigger, because more layers will accumulate, and ultimately this way a sleet which is as small as a water droplet might turn big as almost, you can say, a lemon or a golf ball, bigger than table tennis balls also. They are many times bigger than table tennis ball, right? So you can see here, maybe एक diagram इसका image होगा. You can see something like this. What is this? This is hail, right? And I hope most of you can see that at the center of that hail there is something which you can see. That is that frozen first droplet, right? And around it every time another concentric layer goes on growing, and finally it will become big enough. And hail, if it falls on, you know, surfaces such as glass or head, so they can be damaging. इतना ही बोलना चाहिए, right? So sleet will generally not cause any damage to you, right? It's just like small droplets falling, but hail can be damaging. Okay, do we understand this? So what is the additional condition for hail formation? In addition to sleet conditions, you need additional rising convection. ठीक है? So should we write that as well? लिख लें? Should we? Any major doubt? No. Now you might ask me, sir, in what cases will I get this convection? Convection कब बनता है? On the earth surface. One, during summer. Second, mechanically caused convection. Third, orographically caused convection. So in mountainous regions, you will get this kind of hail formation in winter or summer, both the season. But in plains, when do you generally get hail? Summer. It is early summer part when you get hails. Okay, hail is a early summer phenomenon. That's why in regions such as West Bengal, Jharkhand, Odisha, hail happens somewhere around April, May. This is the period. Next few days, you will start seeing hail images coming in the newspaper. Okay? So you need a convection, and convections will generally happen during this slight summer period. So they will be able to, you know, carry those frozen droplets back and forth, and then ultimately. So let us write this down. So hail, I hope you have written the subheading. Under that, write down hail formation requires conditions. Hail formation requires all the condition of sleet formation. Hail formation requires all the condition of sleet formation. And in addition to this, it also requires some rising convection caused thermally, mechanically or orographically. Thermally, mechanically or orographically. Right? Orographically. But in cyclones, you generally don't get it. Why? Because in cyclones, even in upper atmosphere, the winds are strong. So if there is a very strong wind, freezing condition cannot sustain there. Any frozen wind, even if it comes, it will be driven away. Okay, so in cyclones, you generally don't get this hail formation. Right? Because upper atmosphere winds are also very strong. Is that all right? Right? So you get it up to the convection, orographic, all these conditions. Hence, hail formation can happen in summer or winter in different regions. can happen in summer or winter in different regions. Different region. Next paragraph, formation process. Hail formation process. वो process नहीं लिखा है हमने. Hail formation process. Okay, continue to write as. And have you drawn this diagram? All of you, right? ये rising convection भी लिख लीजिए उसी में. Rising convection. So you can write once the sleet is formed. Once the sleet is formed. Sleet is formed, comma, in the presence of a rising convection, in the presence of rising convection, the frozen sleet drops are carried back. Sir, are hail same as ole? The answer is yes. Yogesh Tikam. Okay, so in Hindi we call it as ole. Alright? Very good. The sleet droplets are carried back into the clouds. The sleet droplets are carried back into the clouds where they accumulate more water. Where they accumulate more water, become bigger, accumulate more water, become bigger, and again fall down, to freezing zone, so as to refreeze again. Full stop. This is the formation of hail. This is the hail or formation of hail, which can be carried back and forth. A few times. Comma, every time making the hail bigger in size. Every time making the hail bigger in size till it finally drops due to its weight. Alright? Clear? नहीं? पूछो? Clear या नहीं है? Clear? Okay. Good. Right. So, good. So that's it. These are your 4 forms and processes. सब कुछ clear हो गया? Now here you have to understand one very fine difference which many times people confuse with. There is a difference between form of precipitation and processes causing precipitation. Which are the forms of precipitation? Forms कौन सा है? Rain, snow, hail, sleet. And which are the processes causing precipitation? Convection, orography, cyclonic. ठीक है? And many times they ask you types of precipitation. अब now the word type is not very clear. Right? What are they asking? है ना? So type के अंदर क्या क्या हो गया? Type can include the forms and type can also include the process. ठीक है? So if the question is asking just type of precipitation, I would generally, because when you read your books such as G.C. Leong and all, there in types of precipitation they are only giving you the forms of precipitation. शायद जहां तक मुझे याद आ रहा है. ठीक है? But I would generally recommend that if you are writing a mains answer, please do write all the parts. If they are asking only, if the word is only type, then give both. If the word is only form, then give only form. And if they ask you different processes causing precipitation, तो सिर्फ process देना. Is this okay? ठीक है? आगे बढ़े. Very good. So now, once we are done with this form and type of precipitation, next is precipitation distribution on the Earth's surface. Which region gets how much precipitation on Earth? Okay. So next one is precipitation distribution on Earth. Precipitation distribution on Earth. So now you have to just apply a bit of what you have learned till now and what factors cause precipitation. If I ask you, where do you think precipitation should be more, or what should be the pattern of precipitation when you go from equator towards pole? What should happen? Decrease. Why do you think so? क्यों decrease होना चाहिए? Because the temperature is less, the evaporation will be less, right? Absolute humidity will be less, and hence the precipitation should also decrease. Is this okay? The number of times it happens might be more, but the total amount might be less. Do we get it? So the overall precipitation amount will decrease as you go from equator to pole, because air's moisture holding capacity becomes less. Is this okay? So this is the first thing, that as we move from equator to pole, the general precipitation amount decreases. As we move from equator to pole, precipitation amount decreases in general, or general precipitation amount decreases. Okay. Now next, which region on the earth should receive more precipitation? Which region is more on the earth, by the way? Oceanic or continental? So which region should receive more rainfall? Oceanic. Most of the rainfall happens over the oceans. Okay, because total ocean is more. So लिखना है. Most of the precipitation takes place over ocean, because there is more oceans on the earth. Most of the precipitation takes place over the ocean. Right? And if you take a unit area of ocean and unit area of land, then still more rainfall happens over ocean. Unit area समझते हो? If you take 1 square kilometer of ocean and 1 square kilometer of land, where will more rainfall happen? Ocean. Why? Because over the ocean humidity will be more. One is overall ocean itself is more. Second, even on 1 unit area of ocean, more rainfall happens. Why? Because evaporation is more. Because oceans, more evaporation can happen. Okay? So that's the next thing. Comparing between continental and maritime regions. Maritime regions receive more rainfall. Maritime regions receive more rainfall than continental regions. Hence, coastal regions should receive more or less as compared to interior land. Coastal regions would receive more rainfall as compared to interior land. Coastal regions will receive more rainfall as compared to interior land. Okay. Next, suppose this is the continent. Okay, and this is like 10 degrees to, or 0 degrees to 30 degrees, and this is 30 degree to 60 degree, and this is continent. Obviously this side is ocean, this side is also ocean. So if I ask you between 0 and 30 degree, if you move from east to west, right? By the way, which winds blow in the 0 to 30 degree region? Easterlies. So the easterlies will be blowing something like this. All of you agree? Aisa? So where will they pick the moisture from? Eastern side of the ocean or western side of the continent? So when the winds will blow like this, which side of the continent will they cause more rain, and which side of the continent should I expect less rain? Or simply said, as you move from east to west over the continent, rainfall should. If you move from the eastern side to the western side of the continent, rainfall should decrease. Do we agree, everyone? वो लिख लीजिए. Right, in the equatorial tropical region, as we move from eastern side to western side of the continent, the rainfall gradually decreases. And what is the cause of this? Many times they give you reason and assertion questions. इसका reason क्या है? Because easterlies pick the moisture from eastern side of the continent. If you want, you can write that reason also. Because easterlies pick the moisture from eastern side of continent. Eastern side of continent. Okay. ठीक है. Second, 30 to 60 degree. What should be the trend? Just, अच्छा, you have a doubt? हाँ बोलिए. बट वो करेंगे तब जब हम वर्ल्ड क्लाइमेट करेंगे. ठीक है. दैट्स नॉट द ओनली रीजन. दिस इज वन ऑफ द रीजंस. और भी रीजंस है. वी विल सी दैट. ठीक है. बट इट इज अ सब्सटैंशियल रीजन. ओके. सो नाउ 30 to 60 degree. What should be the trend? As you move from east to west, in the 30 to 60 degree, as you move from east to west, rainfall should increase, है ना? Because the westerly will pick the moisture from west. So इसका उल्टा ही बोल सकते हैं. That when you in the 30 to 60 degree, when you move from west to east, rainfall should decrease. ठीक है. So we'll write this one. Right? What? When we move from, in the 30 to 60 degree, in 30 to 60 degree latitude, when we move from west to east, 30 to 60 degree, when we move from west to east, the rainfall increase या decrease? Decrease. West to east. ध्यान से लिखना. When you move from 30 to 60 degree, when you move from west to east, the rainfall decreases. दिल्ली वाला decrease, इंडिया वाला increase नहीं. ठीक है. सो डी से स्टार्ट होता है. और बाद में पता चला उल्टा पुल्टा लिख करके फिर मेरे पे ही ब्लेम डालोगे. क्लियर है? ओके. सो वेरी गुड. नाउ द नेक्स्ट वन. So this is your broad, so you can write next. Above are the broad distribution of precipitation. Above is the broad distribution of precipitation on earth. Above is the broad distribution of precipitation on earth. And on this basis, different regions are classified differently. Different regions are classified differently on how much rain they receive. On how much rain they receive. For example, the average precipitation of the earth, is around 100 centimeter per year. Is around 100 centimeter rainfall per year. Okay. And the India average India average is around 115 centimeter per year. 115. Some sources write up to 125. Even that is okay. So if the exam gives you up to 125, even that is okay. 115 to 125, that's okay range, because your NCERT says something like 125, and if you see the IMD articles, they go up to write something like 116, 116 or 115. तो मैंने कितना बोला आपको? Round of 115, 15 to 125. That's the India average. Is this understood? So on an average, India gets more or less rainfall than the world average. More rainfall. India receives around 15 to 25% more rainfall than the world average. That's the first thing. Is that okay? Very good. Now, how do you measure rainfall in centimeter? Centimeter का मतलब क्या है यहाँ पे? What does this centimeter, millimeter rainfall मतलब क्या है? Height of rain. So where do you accumulate it? Anywhere? Where? Which surface? हाँ, मतलब आपका मान लो आपका बालकनी में पानी इकट्ठा हो गया, उसको नाप के आप बोल सकते हैं इतना रेनफॉल हुआ. आई एम जस्ट आस्किंग, कैन यू डू इट? कैन यू मेजर इट ऑन योर रूफ? पक्का? अच्छा, इफ ऑन योर रूफ इफ यू ब्लॉक ऑल योर नाला, कैन यू मेजर इट? स्टिल नो. कैन यू मेजर इट इन अ ग्लास? हाँ, यस और नो? नो, यस. कैसा मेजर करेंगे फिर बोलो? हाँ, ओपन सरफेस मतलब छत तो ओपन सरफेस ही था ना, छत पे ग्लास रख देंगे. बिल्कुल सही है, नथिंग रॉन्ग. यू कैन मेजर इट इन अ ग्लास, यू कैन ऑल्सो मेजर इट इन योर balcony, you can also measure it on your roof, provided, now please listen, provided the surface at the bottom and the surface where the rain is falling or collected from is same, and it's a flat region and no water escapes. ठीक है? So if I take a bottle like this and open it and keep it, then you won't get it. Why? Because the top area is small and the bottom is wide. But if I cut it in the middle, ऐसा ऐसा कट करके और छत पे रख दूंगा, ठीक है, even this bottle will give you how much millimeter of rainfall has happened. Why? Because the top of the bottle and the bottom of the bottle have same area, and you have kept it in an open place, as he said, right? And lastly, no water is escaping it. You get it? Why? Why will that be so? Your roof and let's say if you do the same with your roof, normally assuming that your roof doesn't have irregular surfaces, if your roof is a flat roof, तो आप अपना छत के ऊपर भी मेजर कर सकते हैं, अपने नाली में जाके कुछ प्लास्टिक घुसा दो, ठीक है, and allow the water to accumulate. ठीक है? So after a while, when the rain stops and you go and take a scale and measure, you will get the height of the rain. Why? Because the surface of the roof and the top of that roof, the area is same. Actually, इस एरिया में इतना ही पानी गिरेगा और इसी जैसा 10 बॉटल रख देंगे तो 10 बॉटल के जैसा गिरेगा, लेकिन हाइट तो उतना ही रहेगा ना. The height will not increase. You get it? The collected area will increase. That's okay. But if the collected area is increasing, even the bottom area is increasing. तो हाइट तो उतना ही रह जाएगा. आ रहे समझ में? यू डू दिस एक्सरसाइज, मतलब दिस इज नॉट वेरी इजी टू डाइजेस्ट, ठीक है, बिकॉज दिस विंटर्स आई वॉज एक्सप्लेनिंग द सेम टू माई डॉटर एंड शी वॉज ऑल्सो नॉट वेरी रेडी टू एक्सेप्ट. सो शी सेड नहीं मेरे को विश्वास नहीं है, मेरे को बकेट, एंड थैंकफुली इट वॉज रेनिंग इन दोज डेज. सो शी टुक अ बकेट एंड अ ग्लास. वो फ्लैट सा कुछ बकेट नहीं था, इट वॉज अ कंटेनर इन विच वी कुक राइस. सो शी केप्ट दैट राइस थिंग एंड द ग्लास आउटसाइड, glass, शीशा का glass which is flat, and she gave very strict instruction, nobody should touch it till morning, till I touch it myself and see, and papa you should not do any cheating. मतलब ऐसा ही बदनाम है, ठीक है. तो then she went in the morning and she saw both the water बिल्कुल equal height. She was pretty excited. ये कैसा हो गया? Thankfully I got another chance to explain her a bit of geometry also. ठीक है. So her curiosity took her from geography to related है, हाँ, तो वहां पे then she understood the concept of area and volume also, thankfully. So that all I'm trying to say is that this is what, so basically when you're taking the height of your water, you know, how much it is raining, what they do is they keep a straight beaker in the open, because the top of the beaker and the bottom of the beaker have same area. So जितना पानी इसमें गिरेगा that much water will accumulate at the bottom. right? So at the end of the rain, when you measure the height of the water in that beaker, you will get exactly the same irrespective of the shape. The height will remain same. This height is what you call as this much of rainfall has happened. So on an average, India receives how much rainfall? Nearly 115 centimeters of rainfall, this much. If you keep a bucket and ensure that the water does not evaporate and only accumulates, you by the end of the year you will get this much height of water. Do we get it? Is this clear? Very good. So now on this basis, the regions in the world where we receive rainfall more than 200 centimeter per year, right? Regions where we receive more than 200 centimeter rainfall annually, we call them as very humid or par humid regions. Very humid or par humid regions. Okay. So regions in the world which receive more than 200 centimeter rainfall are known as par humid or very humid region. Par humid or very humid. And which regions will have this kind of rainfall? We have to write that also. उस regions का नाम भी लिखना है. So regions more than 200 centimeter rainfall annually are par humid or very humid, which include equatorial regions. So normally in equatorial region we have this much rainfall. Equatorial regions. Coastal monsoon regions. Coastal monsoon climate regions. And windward western slopes along western coast, in the westerly wind regions, 30 to 60 degree. In the westerly wind region. Okay, so these three regions in the world have par humid, kind of rainfall. Then the second region is, or the second classification is 100 to 200 centimeter rainfall. We call such regions as humid regions. Pehla wala was very humid or par humid. This is humid region in the world. So any region receiving more than 100 centimeter and less than 200 centimeter is called as humid region in the world. And by this definition, India is also a humid region in the world. Okay. Which regions in the world do we get this? Which regions? Generally the coastal areas of continent. This is in general all coastal areas. Coastal areas of continent and interior windward parts of continent. Interior windward. In the continental interior, the windward regions. Continental interior, the windward regions. Okay, for example, northern plains of India are windward when you compare it with respect to the Himalayas. Because in the Himalayas, the winds tend to rise, right? So all the region before Himalayas becomes windward. Is this okay? Okay. Then the third one. The third region is 50 to 100 centimeter rainfall. 50 to 100. We call it as semi-arid region. Semi-arid regions. Semi-arid. Such as the central tropical continental regions. Central tropical continental regions. These are the subtropical high pressure continental regions. And the interior temperate regions. Interior temperate regions. Alright. Then the fourth one are the region less than 50 centimeter rainfall per year. We call them as arid regions. 50 centimeter rainfall called as arid regions. ठीक है, which regions are these? These are the tropical deserts, ठीक है, tropical desert regions and temperate desert regions, tropical desert regions and temperate desert regions. Okay, so where are they? We'll do that, don't worry, but you should know that tropical and temperate deserts have less than 50 cent. We call them as arid regions. Is this okay? So this is your world rainfall distribution and the region classification. Good. With this we come to the end of precipitation also. Now which are the two other factors left? Element of weather and climate. दो चीजें बची हैं, एक visibility and एक one more is there, sunshine. ठीक है. So let us write number 7, sunshine. Sunshine. ठीक है. So factor number, this is element of weather and climate number 7. Element of weather and climate number 6 was precipitation. That we have completed, and now we are on element of weather and climate number 7, known as sunshine. So now please write down. It is the same as insolation. Please write. It is the same as insolation, and hence the same factors affect sunshine. It is the same as insolation, and hence the same factors affect sunshine. ठीक है. So for example, in tropical and equatorial region, which region should I experience more sunshine? Tropical or equatorial? Why? Because equatorial region have low pressure and hence cloud formation. ये सब हमने किया था वहां पे, याद है? That's it, इतना ही लिखना है, उसके सिवाय the topic is over. Same as insolation है, तो कुछ और बचा ही नहीं इसमें. The only relation you have to understand is sunshine is same as insolation. ठीक है, क्योंकि आपका बुक के अंदर टॉपिक दिया है तो इसलिए लिखवाना जरूरी था, नहीं तो आप बोलते तो कराया नहीं सर ने. ठीक है, तो कंप्लीट हो गया एक और. So 7 also done. Right, now let us come to 8. एक ही लाइन लिखना था वहां, खत्म हो गया. मतलब इतना चिंता करने का जरूरत नहीं है, ये क्या हो गया. ठीक है. So if you want you can write there, for example, equatorial regions get less sunshine than tropical region. ठीक है. So but वो नहीं भी लिखोगे तो चलेगा, because you have already written this in insolation. ठीक है. So only writing sunshine is same as insolation and same factors is good enough. Then you just have to go back to insolation and see those factors. वहां पे हमने लिखा था 5-6 factors if I'm rightly recalling, maybe more. ठीक है. So same factors. Then come to next one. What is this? Visibility. Okay, so what things in the atmosphere, what natural thing in the atmosphere will affect the visibility? Dust particles, which means if there is more dust particle, can the air be very humid if the dust particles are more? If there is too much of dust in the air, will the air be humid or less humid? Depends. Dust particles. अच्छा एक बात बताओ, after the rain, do you get more dust or less dust? Which means more rain means less dust, and more dust means less probability of rains. Dust is there generally when the humidity in the air is less. Dry air. Dust is a character of dryness of air. ठीक है. Wet air does not remain dusty. ठीक है. So dust particles are generally in dry air. And when do we call the air to be dry? When the RH, relative humidity, is less than 75%. We start calling it as relatively dry air. ठीक है. So when the relative humidity is less than 75, we start calling it as dry air, and in that the dust particles might be high, not always high, might be high. ठीक है. What are the dust particles? Like sand and all. And we call such condition as haze. So when the relative humidity is less than 75 and there is dust in the air, we call it as haze, hazy air. ठीक है. So we call this as haze, and the visibility in haze is nearly less than equal to 2 kilometers. Visibility. Hazy air, the visibility is up to 2 kilometers. वो मूवी देखा होगा बेल बॉटम, उसका एंड सीक्वेंस, बहुत सारा हेज था, डस्ट पार्टिकल, एक दूसरा दिखता नहीं है उसमें, पढ़ते तो हो नहीं तो मूवी से ही बताना पड़ेगा. हाँ, और भी एक दो मूवीज बताऊं, मिशन इम्पॉसिबल में भी है ना, याद आ रहा है. यस सर, बुक में चैप्टर पूछूंगा तो याद नहीं आएगा. मूवी सारा याद है. वेरी गुड, चलो अच्छी चीज है. विच एवर वे यू रिमेंबर. ओके, यूपीएससी प्रिपरेशन लाइफ एक्सपीरियंसेस से होता है, तो दैट्स ऑल राइट. सो डू यू अंडरस्टैंड दिस? राइट. सो व्हाट डू वी कॉल व्हेन द एयर इज टू हेजी? We call it as, sorry, when there is too much of dust particle, we call it as hazy, and in hazy air normally the visibility is up to 2 kilometers. And what reduces the dust particle? Right, precipitation. Normally rainfall will settle down the haziness, or when the wind stops to blow. Right, when the wind becomes weak, gradually the dust particles over a period will also settle down. Okay, so two conditions, either precipitation or slow winds. Right, when the wind become very slow, over a period it might settle down. Or lastly, very strong winds which might carry away all the dust particles. ठीक है, but normal wind better रहेगा तो वो haziness रहता है. Okay, good enough. Now the second type of visibility, one was dust particle, second is water vapor. Right, the water, or what you call as humidity in the air. So one was dryness and the second is humidity. Humidity in the air also creates visibility problem two ways, such as fog and mist. And this happens when the RH is high, when the relative humidity is high. So you might get fog or mist in the air. What is the difference between fog and mist? In mist, the visibility can be up to 1 kilometer. Right? The visibility might range up to 1 kilometer in mist. So you can see up clearly up to, matlab you can see up to 1 kilometer. In fog, the visibility is up to few meters. Up to few meters. Many times it's not even 1 meter or 1.5 meter. Right? Maybe you can't see things which are just a meter away from you. Has this happened with you? You know, when the fog is extremely heavy fog, you can't see things which are maybe, you know, pretty close to you also. So that is fog condition. Is that okay? What is the difference between fog and mist? दोनों में अंतर क्या है? In both of them relative humidity, both of them cloud type, what is the difference? The difference is size of particles. In fog, smaller, numerous droplets are there in fog. Smaller, numerous droplets are there. In mist, bigger, fewer droplets are there. Bigger, fewer droplets are in mist. So where you have numerous droplets, visibility is less. Where you have fewer droplets, visibility is more. Because it's all about refraction. Visibility goes by all that light entering and, you know, bending. So when the light will bend more, you won't be able to see the things. ठीक है? Clear? So fog and mist is also clear. And one more is smog, which you see in urban areas. But that is more of an environmental concern than visibility concern. Because smog and fog give you similar visibility. So visibility के perspective से smog doesn't have a role. Smog has a role when you talk of environmental pollution and all. ठीक है, तो इसीलिए smog we won't touch here, right? But if you feel like, you can also write fog or smog. Smog you get near on the roads or urban areas or industrial areas. Urban area, industrial area. These areas you get smog. Smoke plus fog. Covered in detail in your environment section. Okay, so with this, all the 8 elements of weather and climate are over. Okay, so ये part complete हो गया, and now it is break time for you. Now what do we do after break? We come to the remaining part of elements of weather and climate. Which part of the element of weather and climate we have not completed? Winds हमने complete नहीं किया है, ठीक है? Which winds? As he said, geostrophic winds नहीं किया है, upper atmospheric. So we have to see, but we won't start with. Let's see अभी क्या करते हैं. So once you come back, we'll try to complete secondary winds. ठीक है? Secondary winds means air masses, temperate cyclone, tropical cyclone, monsoon. अब ये सब हमें करना है, ठीक है? And along with that, we'll also do geostrophic wind, jet streams, Rossby wave, ये सब, ठीक है? So take a 10-15 minute break, come back, and then we start with this part. Sir, any doubt or question you want me to take up? Okay, good. Okay. Right, so should we start? Yes, sir. ठीक है. So now let us start with the remaining part of the winds that we have not completed, because now all the background that you need for understanding this part is ready. So we write winds continued. ठीक है? All right. So we come back to this part of winds, and in this there are parts which we have not completed, included one, upper atmospheric winds. So let us start with that. Upper atmospheric winds. Directly start with this. ठीक है? So in upper atmospheric winds, we have talked of geostrophic winds. Geostrophic winds, hopefully everyone remembers, and we have written 2 subtopics here, Rossby waves and so we have to complete this first and then we go beyond this. Okay, so let us come back to this Rossby wave and the geostrophic wind wala part. Okay. So what do we understand of geostrophic winds? क्या होता है geostrophic wind? What have we done? Can you tell me? They are upper atmospheric winds moving in a west to east direction. Over which latitude have we done? The one that we did was over 30-degree latitude. And why does it move that way? Due to which 2 forces? Pressure gradient force and Coriolis force. And which force is absent? Frictional force. इतना याद है ना सबको? Very good. So this is what we have drawn. ठीक है? This was the diagram, right? So in this you can see the geostrophic winds moving from first in the upper atmosphere. They are moving from equator, and then as they move, they become a west to east winds, something like this. And this was the one that we did, but actually we have geostrophic winds even over 60-degree latitude, right? They are created. I think we wrote that at that time. लिखा था ना? That even over 60-degree latitude, we have the geostrophic winds moving somewhat like this. So we have geostrophic winds over 30 degree and we have geostrophic winds over 60 degree, and they are formed between which two parts of the atmosphere, which two other things in the atmosphere? Below the tropopause, between, for example, the 30 degree one is formed between Ferrel cell and Hadley cell. Okay, I don't know whether we wrote that, but this is what it is. That when you talk of this geostrophic wind which is above 30 degree in the upper atmosphere below tropopause, it is formed between Hadley cell and Ferrel cell, between it. Okay, so this wind is blowing between the two cells, the geostrophic wind over 30 degree in the upper atmosphere, whereas there's another geostrophic wind which is over 60 degree somewhere here, and that will be between polar and Ferrel cell, right? So there's the second geostrophic wind that we'll draw here would be somewhere in this region, yahan pe, moving like this, west to east. All right, that's exactly what we have drawn here, yahan pe, in that other diagram. So 30 degree in below tropopause and 60 degree below tropopause. Is this okay? And that is created because of those two forces that we just did. All right, perfectly fine. Is this much clear to all of us? No major doubt? Could doubt hai major? None? All right. Now, do we call them in the atmosphere in general as geostrophic या कुछ और नाम से बुलाते हैं? This is the second thing that you have to learn. So for example, I'll give you an example that will help you understand. Inside your cars that you have an internal combustion engine. है ना, internal combustion engine है. But do you generally always call it as internal combustion engine? आप क्या बुलाते हो? गाड़ी का इंजन है ना, या मेरा पेट्रोल इंजन या मेरा डीजल इंजन, या डिपेंडिंग ऑन द कार कंपनी, है ना, कि मेरा मारुति का इंजन खराब हो गया है or something like this. Do you get it? So technically it is an internal combustion engine, but you generally don't call it as internal combustion. You call it as whatever brand name or whatever, you know, depending on which region you are in. Similarly, the geostrophic wind is a technical name, right? It is like the internal combustion engine, right? But we generally don't call it as geostrophic winds. We call it by different names. Okay? So the most common name of both the geostrophic winds that we have is Rossby waves. Why? Because one scholar by the name of Rossby found it, and he also found the characteristics of this wind. Okay? So what do we call it as? Rossby waves. So in general, the two major geostrophic winds that we have drawn, 30 degree and 60 degree one, they are also known as Rossby wave. So what is Rossby wave? Rossby wave is nothing but the geostrophic winds which are blowing over 30 degree and 60 degree latitude, cumulatively called as Rossby wave. Why? Because one scholar named Rossby found it. And why do we call it as wave? Because this was the characteristic of this that he found, that this wind is moving not like a straight wind, but it is moving like a wave. Okay? So he called it as Rossby wave, and that's how the name came. Okay? So basically these two winds that you have drawn, they don't move like this exactly. How do they actually move? Over the Earth's surface, they move somewhat like this, like a wave, right? Waving between north and south, not waving up and down, not vertically waving toward the sky and the surface of the earth, but waving poleward and equatorward, like this in the upper sky. The way snake moves on the ground, how does the snake move? ऐसा move करता है ना, ऐसा on the surface. Snake ऐसा ऊपर नीचे move नहीं करता है. देखा किसी snake को ऐसा जमीन के ऊपर चल कैसा चलता है वो? Sideways, right? So these waves also move sideways on the surface. What moves like this? Move करता है. You might have seen. हाँ? Rope नहीं, living forms में भी कुछ ऐसा होता है, वो ऐसा jump करके चलता है. Have you seen? There is a variety of, you know, these worms, right? So they tend to move straight. ऐसा walk कर, मतलब, you know, they will move like. Have you seen? कुछ not all worms, but some worms tend to move vertical wave like. ठीक है? So same way, जैसा कि हमने earthquake में पढ़ा था, horizontal wave and vertical wave, ऐसा. ठीक है? So this wave moves on the surface of the earth, going west to east, waving north and south. Is this clear? This north and south waving is should be very clear, क्योंकि बाद में आप लोग यही आगे मुझसे पूछते हो, सर ये तो ऐसा चलना चाहिए था, आपने ऐसा बताया था, because that creates lot of confusion in the later stages. क्योंकि इससे on this depends lot many things that we have to do. So what is the wave shape? North-south sine wave. This is a north-south sine wave. Do we get it? So this is what you call as the Rossby waves. These two waves are known as Rossby waves. What latitude? 30 degree and 60 degree. Where? Below the tropopause. Between the 30 degree one is between Hadley cell and Ferrel cell. 60 degree one is between polar cell and Ferrel cell. Is this clear? Below tropopause, moving like a wave. All this is clear. Okay. Now, what is the width of this? The width of this can be a few tens of degrees. You know, it can be something like 10 degree or so, which means approximately 1,000 kilometer wide wave. 1 degree is how much? 111 kilometers. So, अगर 10 degree wide है, तो कितना wide हो गया? Nearly 1,000 kilometer wide. Right. So, this is almost 1,000 kilometer wind wave. All right. Right. So, maybe up to 10 degree wide, and this degree is latitude. 10 degree latitude wide, right? So nearly 1,000 kilometer wide, and the wind speeds are slow in this. The wind doesn't move very fast, so wind speeds are slow, around 50 kilometers per hour or more on an average. The average wind speed, not the exact wind speed, the average wind speed of the Rossby wave is something like 50-60 kilometers, less than 100 kilometers. ठीक है, average wind speed less than 100 kilometers, something like 50-60 kilometers. Okay, clear है? So average speed is less than 100 kilometer, something like 50-60 kilometers. All right, and the width you have written and this part also. Is this much clear? Now, when I say average speed, it is the average speed like what? It is the average speed, for example, if I make all of you run, right, on a 100-meter track, and then I find the average speed of all of you. So some of you might run very fast, and some of you might run very, है ना, बोलने के बाद ये धीरे धीरे चलते रहेगा देखते हुए कि सर तो नहीं देख रहा है, जैसे स्कूल में होता था, हाँ देख रहा है तो थोड़ा सा जंप मार लिया 2-4, उसके बाद नहीं देखा तो. So what is the average speed? Take the average of all, and that's what your average speed is. So Rossby wave का भी वैसा ही है. Some part of this moves very fast, some part of this moves very slow. Hence the average comes to something like 50-60. Is this clear? Right? So Rossby wave ho gaya, that's all. You don't have to know anything else about Rossby wave. This is the only thing. These are the characteristics, the region, and that's it. Is this okay? Can we move beyond Rossby wave? Right? आगे चले? Very good. Now the next thing is what? Jet stream. So put the subheading, jet stream. Right? And let us try to understand what are ठीक है. तो ये क्या है ऑन द बोर्ड? व्हाट इज दिस ऑन द बोर्ड? अभी सीखा आपने. दे आर लाइक द, उसके पहले क्या पढ़ा वो नहीं पूछा मैंने, मुझे पता है. यू माइट हैव रेड, जो सर छुपा रहे थे, ठीक है, इससे पहले कि सर छुपा दे पढ़ लो, ठीक है. तो व्हाट इज दिस? Rossby wave. This is your Rossby wave. Okay. But as I said, Rossby waves are pretty wide as almost 1,000 kilometer wide, and the average speed, so they are slow wave-like motion, right? And they are like the same wind thing moving. So now I hope you can imagine that if you have a wind which is almost 1,000 kilometer wide and the whole thing is moving with an average speed of 50 kilometers, you can imagine that as you get to the center of that wind, the wind speed should be higher or lower? It is like the river. If you have a very big river, so when you go to the outer side of the river, on the bank, the river speed is, but when you come to the center of the river speed becomes, can you imagine? All of you have seen this. So same ways in this Rossby wave also, when you come to the center of the 1000 kilometer, let us say you're talking about center 10%, what should be the wind speed? High speed? Can you imagine? So in the center of these two Rossby waves, or these four Rossby waves at 30 degree and 60 degree on the earth, we have very fast speed moving winds. And those extremely fast speed moving winds are what we call as jet stream. So jet stream kuch bhi nahi hai. Jet stream is broadly, not always but broadly, or not always, I'm repeating this, not always but broadly, the jet stream is like this. Okay, that's why I just hid it. So when you talk of the Rossby wave, it is like this, and when you go to the center of the Rossby wave, what you find? You find the jet stream. So at the center of every Rossby wave, you will find a jet stream. But what is the jet stream? Nothing but the part of the Rossby wave where the wind is moving at a extremely high speed. Why? Because the friction is less. As you go on going to the center, the friction will be less. So the friction becoming less, the central wind blows very fast, and that's what you call as jet stream in general. Right? There are exceptions to this also. There are some jet streams which are not formed this way. We'll talk of that later. But all the major jet streams that we know are formed this way. Itna clear hai? Do we get it? Hai na? So now under that jet stream thing you can write at the center of Rossby waves. At the center of Rossby waves, we have very high speed, 100 to 300 kilometers per hour. At the center of Rossby waves, we have very high speed, within bracket 100 to 300 kilometers per hour, winds moving in a relatively narrow zone, within bracket nearly 100 to 150 kilometer wide, nearly 100 to 150 kilometer wide, so what is the width of the jet stream? 100 kilometers, approximately 100 kilometers wide, and 2 to 3 kilometer vertical height. 2 to 3 kilometer vertical height. What is the vertical height? Below tropopause, what is the height up to which it goes? Okay, 2 to 3 kilometer. So when you talk of the different, so something like this will be 150 kilometers and something like this is 2 to 3 kilometers. Though the size doesn't show that well, this is 2 to 3 and this is something like up to 100 kilometers wide. Do we get? And will the jet stream be above tropopause or below tropopause? Between cells such as Hadley cell and Ferrel cell. वही है, because it is nothing but the Rossby wave. Will it also wave? Yes, jet streams also wave. ठीक है, वो भी wave करेंगे, but they might not wave exactly as wide as the Rossby wave, because Rossby wave was 1000 kilometer wide, so उनका wave ज़्यादा बड़ा होगा, and the jet stream in the center would have a relatively smaller wave, but even they tend to wave. Is this clear? Do we get it? So what are broadly the jet stream? They are nothing but part of Rossby wave because of low friction. So वो part अभी लिखना है. So wind speed we have written 100 to 300 kilometer. ठीक है. Width also we have written, right? 100 and the vertical height is 2 to 3 kilometer. Next, write down. They are formed in the center of the Rossby waves. They are formed generally in the center of the Rossby waves. They are formed generally in the center of Rossby waves. Center of Rossby waves. Due to extremely low friction in this region. Extremely low friction in this region. Full stop. They also wave north to south. north to south, and generally are formed due to the pressure gradient, and generally are formed due to pressure gradient force, and generally are formed due to pressure gradient force, which is mainly due to thermal gradient or temperature gradient, which is due to temperature gradient. All right. So this is the general characteristic of jet streams. All right. Now the major jet streams on the earth. Yes, they are. Rossby wave and there is no friction. Okay, very good. So see, okay, I got your question. I think broadly, why do we have these two and why do they behave differently? That's your question, right? Basically, when there is no friction in the upper atmosphere, the whole thing tends to create a Rossby wave because of less friction. But as the movement starts within that, it is just imagine that like a big pipe. So as something is flowing in that big pipe, which is almost 1,000 kilometer wide and maybe 6-7 kilometer vertical height, as you keep going into the center of this pipe, between the moving particles also, the friction will go on decreasing. So it's a relative motion of the outer ones moving slow, right? So suppose सबसे बाहर जो है non-moving air is constant, so the friction that the Rossby wave gets from the non-moving air is less. But as this air is moving, the air inward of this will get lesser friction from this one. So suppose this is moving at 30 kilometer, this might move at 40. So relative speed कितना है 10 kilometer. So कम ही friction हो रहा है ना? Do you get it? And then next one to that will be moving at 45. So this way gradually the speed will go on increasing to the center. Right? So ये relative friction है between moving particles. Is that okay? बाकियों को अगर ज्यादा मतलब नहीं समझ में आ रहा तो कोई दिक्कत नहीं है, जरूरी भी नहीं है कि समझ लें. ठीक है, जितना समझना था उतना हम समझ चुके हैं. राइट, रेस्ट इज फिजिक्स. तो फिजिक्स में घुसना नहीं है जबरदस्ती. ऑलराइट, सो व्हाट डू वी गेट अभी क्या, व्हाट डिड वी राइट? द मेजर जेट स्ट्रीम्स. समबडी एल्स सेड सर, कोई और डाउट है? नो, चलिए ठीक है. सो मेजर जेट स्ट्रीम्स. सो व्हेन यू टॉक ऑफ द मेजर जेट स्ट्रीम्स, व्हिच आर द मेजर वंस? The first, because of the ones that we have already done, उसके पहला वो लिख लेते हैं. The first one is called as your subtropical jet stream. The first one, subtropical jet stream, formed over what latitude can you see on the board? Subtropical, formed over 30-degree latitude below tropopause between which two cells? Hadley and Ferrel cell. ये सब लिखना है हमें. Right? Subtropical jet stream formed over 30-degree latitude below tropopause. Formed over 30-degree latitude below tropopause between Hadley and Ferrel cell. Formed over 30-degree latitude below tropopause between Hadley and Ferrel cell. So this is that geostrophic wind that we first did. ठीक है? Right. This jet stream moves west to east. We also call it as subtropical westerly jet stream. Moves west to east. Moves west to east. Shifts with the shifting of pressure belt. Shifts with the shifting of pressure belt. Each of them are different characteristics of the same. Shifts due to shifting of the pressure belt between 20-degree to 35-degree latitude. Shift due to shifting of pressure belt between 20-degree to 35-degree latitude. Wind speeds can be as high as 300 km per hour for this jet stream. Wind speeds can be as high as 300 km per hour, leads to formation of subtropical front leads to formation of subtropical front. What it is, we'll discuss in a while, don't worry. Underline that. Leads to the formation of subtropical front and hence subtropical temperate cyclones. Subtropical temperate cyclones. Full stop. Such temperate cyclones, such subtropical temperate cyclones, such subtropical temperate cyclones, when moved from Mediterranean region, over the West Asian region, to the Indian subcontinent, over West Asian region to the Indian subcontinent during winters, bring winter rains, especially in northern India. Known as, what do we call such winter rains in northern India? Western disturbances. Known as western disturbances. Okay, so western disturbances, what type of rain? It is a subtropical cyclonic rain. Cyclonic है ना, वो cyclone form करता है. So this is a cyclonic rain. We'll discuss in detail. Don't worry, it will come later on. So do we understand the subtropical westerly jet? Clear है? It also has a role in Indian monsoon. This jet stream also has a role in Indian monsoon. Okay, so jet stream number 1 done. Now let us come to jet stream number 2. Polar frontal jet stream. Polar frontal jet stream or polar front jet stream as we call it. Polar front jet stream or polar frontal jet stream. Right, that's the second jet stream. Formed over what latitude? 60 degree. Polar front jet stream formed over 60 degree latitude below tropopause. Between which two cells? Ferrel and polar cell. Found between Ferrel and polar cell. Shifts due to shifting of pressure belts. From 45 to up to 70 degree latitude. 45 up to 70 degree latitudes. Formed at a height of 9 to 12 kilometers from the surface. 9 to 12 kilometers from the surface of Earth. Height of 9 to 12 kilometers from surface of Earth. Related to formation of polar fronts. And polar front cyclones. Polar fronts and polar front cyclones. Wind speeds 150 to 300 km per hour. Wind speed 150 to 300 km per hour. Okay, did we write the height of the subtropical jet stream? वहां नहीं लिखा है ना, वहां पे भी लिख लीजिए. The height, average height is 14 to 16 kilometer. The subtropical westerly jet average height 14 to 16 kilometer. ठीक है, clear? Right, now the third jet stream. So that's it, that's the second jet stream is that much. Then you come to third jet stream called as polar night jet stream. Polar night jet stream, यहां पे दिख नहीं रहा है, वो बोर्ड पे बना हुआ नहीं है. Polar night jet stream. Okay, polar night jet stream. By the way, when do we get polar nights? Round the year or specific time or once in a day? 6 months. So polar night jet stream का मतलब क्या है, कितना ड्यूरेशन का जेट स्ट्रीम है ये? It's a 6 month jet stream. ठीक है, so we have to write. This is a jet stream formed over the poles during nights. It is a jet stream formed over pole during nights only for 6 months. It is a jet stream formed over pole during night, hence only for 6 months. Only for 6 months. And during that pole's day, which means summer, will you find the jet stream? No. So this jet stream ends when the winter ends on the pole. ठीक है, the jet stream ends when the winter ends on that pole. The jet stream ends when winter ends on that pole. So it's just like an envelope, you can answer the student. So that's just like an envelope. So there's no fixed height, it will just extend by another 1 or 2 kilometers on each sides. Okay. So ends when the winter ends. So basically it's a polar night jet stream only. Clear? And other characteristics, write down. It is formed beyond 60-degree latitude up to 90. Not up to 90, beyond 60 degree. So 60 to 70 degree latitude. It is formed beyond 60 degree up to 70, 75 degree latitude. And it is associated with the phenomena of polar stratospheric clouds, and polar vortex. So we'll do this later on. We don't need to get deeper into this. Okay, that's it. इतना ही हमें चाहिए. What is, so one, they are formed. Where are they formed? 60 to 75. When? During polar nights. Do they remain in the day or the summer period? No. What are they related with? Formation of polar stratospheric clouds and polar vortex. Bas itna. This is broad enough. So once we talk in the polar vortex and all, there we'll get into slight more detail. ठीक है? So now, so 3 jet streams done. कितना हो गया? 3 हो गया ना? Now the fourth one, tropical easterly jet stream. Tropical easterly jet stream. This is to your question dear. जैसा आपने पूछा था ना, you can see here, as you go from the out to the inward, the wind speed goes on increasing. तो ये internal friction कम होता रहता है इसका. ठीक है? Okay. So tropical easterly jet stream. So as the name says, what should be the direction of this jet stream? अभी तक आपने जो तीनों jet stream किया है, what is the direction? I think we did not write it for polar night jet stream. That is also a west to east jet stream. So the subtropical westerly jet stream, that is west to east. Polar front jet stream, that is also west to east. And polar night jet stream, that was also west to east. So all the three west to east. But this one is tropical easterly jet stream. Easterly का मतलब what should be the direction from which it is coming? East. So it is a east to west jet stream. Okay, so you have to write, unlike the above three, this is a east to west jet stream. East to west jet stream formed during June to September. East to west jet stream formed during June to September. Only in the northern hemisphere. Only in the northern hemisphere. Over the Indian subcontinent and northern Indian Ocean. Over the Indian subcontinent and northern Indian Ocean. Indian subcontinent and northern Indian Ocean between 30° north and 8° north latitudes. Between 30° north and 8° north latitude. Okay, and the height is 14 to 16 kilometers. You have to correct the previous one. वहां मैंने थोड़ा गड़बड़ लिखवाया है, but we'll come to that later. पहले यहाँ लिखिए 14 to, height is 14 to 16 and subtropical वाला you have to correct, that is 10 to 14. I think वहां पे मैंने 14 to 16 बोल दिया है, so just correct it. That is 10 to 14 subtropical. उसका height correct कर लो बस. Subtropical was 10 to 14 and this is 14 to 16. Okay, wind speed is generally around 100 km per hour. Wind speed is generally around 100 km per hour. This is not formed due to any Rossby wave, right? And the formation we'll discuss during monsoon. वो भी लिखना है. This is not formed due to Rossby wave and formation we'll discuss during monsoon. Not due to Rossby wave and the formation we'll discuss during monsoon, as it is related to the concept of monsoon. The tropical easterly jet stream is related to the concept of monsoon and also pushes tropical cyclones of Bay of Bengal, also pushes tropical cyclone of Bay of Bengal over the Indian peninsula. Over the Indian peninsula. Okay, now please see on the board. You can see here tropical easterly jet stream, this one, right? And it is moving over that Indian subcontinent and in northern Indian Ocean region. It is formed only in this region. Okay, so this is a jet stream which is formed only in this region and it is not formed around the year. It is only a June to September over Indian region in summer, not due to Rossby wave but because of other factors which we'll discuss, and it affects the monsoon and tropical cyclones of Indian Ocean. Okay, so tropical easterly jet also done. Jet stream number 4. Now come to jet stream number 5. Somali jet. वहीं पे देखो सामने दिख रहा है. You can see. Can you see Somali jet? All of you in Africa, right? So just draw that Somali jet stream, right? मतलब draw as in just write that name, Somali jet stream. We write and you will get a sense. So Somali jet is formed parallel to the Somali coast. Is formed parallel to the Somali coast, moving over Indian Ocean. Moving over Indian Ocean to the Indian peninsula moving over Indian Ocean to the Indian Peninsula, pushing the summer monsoon towards India. Summer monsoon towards India, also known as southwest monsoon of India. Also known as southwest monsoon of India. Hence, is it helping the monsoon or by pushing the monsoon towards India? It is broadly assisting the Indian summer monsoon, right? वो लिख सकते हैं. Hence, it is broadly assisting. Hence, it is broadly assisting the Indian summer monsoon. Okay, good enough. So that's it. With this we come to the end of Rossby wave jet stream also. ठीक है, so upper atmosphere wind completed. ठीक है, upper atmosphere winds completed, and then we come to the secondary winds. Yes, yeah. See, tropical easterly jet stream we'll discuss. Somali jet stream we don't have to get into. Okay, the remaining polar night jet stream is also formed due to temperature gradient in the winter, because in the winter season the temperature over the pole become extreme. Okay, because of the high temperature gradient, pressure gradient will be created. Because of that, the jet stream is created in that region. Broadly we have to get into this. Okay, more detail not required for GS. Okay, because they have never asked you those questions. They have not even asked you the normal jet stream formation. Polar night तक तो ऐसे नहीं जाएंगे. ठीक है. So first they would be asking you something like formation of subtropical westerly jet stream and all. वो geostrophic wind, उसका ही question नहीं पूछा आज तक. Do we get? So should we come to the secondary winds? ठीक है. So when you talk of the secondary winds which are remaining, secondary winds. In this, I hope everyone remembers whirlpools. What were whirlpools? Whirlpools by themselves were nothing but spiral motion. Okay? And then we learned that there are two types of whirlpool, inward whirlpool and outward whirlpools. Right? So you have outward and inward. Which are the outwards? उनको हम क्या बोलते हैं? Cyclonic or anticyclonic? Anticyclonic. So outward whirlpools are also called as anticyclonic. And in this, will I get rising winds or descending winds? Anticyclonic. Vertically in or vertically out? Horizontally. देखो अब यहाँ गड़बड़ किया तो फिर गड़बड़ होगा यार. I need the right answer. If you want to check your answer, check your copy, do it. But don't give me a wrong answer right now. So in an anticyclone, vertically, inward or outward? Vertical. And horizontally? Everyone agrees? Horizontally? वही तो सामने लिखा है ना. Spiral out कैसे होगा यार अगर horizontally out नहीं है तो? Spiral out के सामने लिखा है ना. तो अगर spiral out हो रहा है तो it must be horizontally outward. तभी तो spiral करेगा ना बाहर को. Spiraling is the characteristic, but it is moving outward. So if it is horizontally outward, then vertically it has to be. So if the wind is moving vertically inward to a surface high pressure, is the wind rising or coming down? If the wind is coming down, will it cool down? Will it condense? Will it form cloud? Will it form rain? No, वो सब नहीं होगा, उल्टा wind है ये. It is coming downward, so the wind is not cooling, the wind is warming up. है ना? ऐसा wind, because of being compressed, it will go on becoming warm and warm. So its capacity to hold moisture will be high, so rain will not happen. Relative humidity will become less. So in anticyclone, this anticyclonic condition, as the wind descends, will it cause rain or will it cause clear sky? Clear sky. So anticyclone is always associated with clear skies. Okay, anticyclone means clear sky. You will not get rain. It is opposite of rain. Okay. So anticyclonic condition, which means clear sky, cloud or no cloud? Cloudless, clear sky, cloudless, no rain, strong winds or weak winds? साइक्लोन में क्या होता है? साइक्लोन, स्ट्रॉन्ग विंड. सो यहां पे क्या होना चाहिए? बिकॉज द विंड इज स्प्रेडिंग फ्रॉम नैरो रीजन टू वाइड रीजन, सो स्पीड विल बिकम लेस. सो वेरी वीक विंड. ओके, वीक विंड्स, weak wind. So this is not a climatic condition to discuss. Why? Because nothing is happening. कुछ हो ही नहीं रहा इसमें. Right? That's why we do not discuss anticyclones. आपका बुक में भी एंटीसाइक्लोन बहुत ज्यादा नहीं डिस्कस है. Why? Because nothing is happening. It's a clear sky. Everything is perfectly fine. ठीक है? Right? So this is a fair weather condition. We also call it as fair weather. Fair weather condition, a fair weather condition or a clear weather condition. Is that okay? Now, so outward anticyclonic whirlpool we have already. So do we discuss anticyclones hereafter in the class? No, no place. Right? Wherever anticyclone is happening, we won't discuss it. Now, what is the other type of whirlpool that we get? Inward cyclonic, nahi. Inward, and inward gives you what you call as cyclonic condition. Inward spiral, cyclonic condition. Inward spiraling winds you can write. Inward spiraling winds give you cyclonic condition. What are cyclonic conditions? Opposite of what you have written there. So will it be clear sky or clouded sky? Clouded sky. वो सारा condition लिखते जाइए. So inward spiraling wind with rising winds, clouded sky. Should I expect precipitation? Heavy precipitation or precipitation at least? And wind should be strong winds. Strong winds. So all this is what you call as the cyclonic condition. And hence, because this is so this becomes a fair weather or a bad weather condition? Bad weather. Right? So all of this collectively is your bad weather condition, and hence we discuss it. Because it affects us adversely. Okay? So we tend to discuss. So this is it. Right? This is what you call as your cyclonic condition and all. And in all of this, what is the common thing which is happening to the wind? The wind is moving, spiraling inward. And depending on the hemisphere, it will be anti-clockwise or वो दूसरा चीज है. That depends on hemisphere. But what is common? Spiraling inward. So this spiral shape, ये जो spiral shape है, right? There is another name for it in geometry. We call that kind of shapes as vortex. ठीक है? So spiral shapes are also called as a vortex shape. Vortex. Something like this. Okay, and this is a normal natural phenomena in nature. Right? There are numerous things which have a vortex shape. Flower के अंदर भी vortex shape होता है. ठीक है? If you see the petals of the flower, you will find that vortex shape. Right? If you see the spiraling galaxies, even in them you will find the spiral shape or vortex shape. Galaxy में देखा है ना? ठीक है, तो उसके अंदर भी ऑलमोस्ट वैसे ही शेप होता है. Yeah, it is not exactly. So I won't get into this golden ratio thing, that number, but it is more of the Fibonacci series that you have. ठीक है, ऐसा होता है ना Fibonacci series, स्पाइरल ऐसा ही बनता है उसका. 1 plus the next number you get 3, and then 2 plus 3 you get 5, and 3 plus 5 you get 8, and याद है कुछ मैथ्स में किया होगा. ठीक है, so that is a natural, that's the natural ratio. ठीक है, and from that only you get, there's a relation between that, but let's not get into that maths right now. But broadly, do we understand? So what is a vortex? The vortex is very simply the spiraling shape, because that's the shape of motions. When the energy is contracting, it tends to contract into a vortex, and when the energy is expanding, it tends to expand into a vortex type of shape. Right? Not only energy, anything, any formation also, as I said, in nature also, if you see the flower petals and all, वहाँ पे भी वही चीज दिखता है आपको. Okay, not only that, when you see the snail growing, snail का shape देखा है, उसका भी जो back वो पीछे का वो पूरा वो बना होता है, वो भी पूरा spiral वैसे ही बना होता है. Anyways, come back. So when you talk of these vortex, in the atmosphere, you have 3 types of inward vortex, 3 regions where you have these vortex. ठीक है, which are the 3? One of them tropical cyclone. ठीक है, तो एक inward vortex हमें एक तो हम सबने देखा हुआ है और at least सुना है. What is that? Tropical cyclone. So in the temperate region we call that vortex as in the tropical region we call it as tropical cyclone. So when you talk of these vortexes, depending on 0 to 10 degree, first of all, should I get a vortex here? For vortex you need which force? Coriolis force. और यहाँ पे तो होगा नहीं. So no vortexes, no vortex, and hence no cyclones. No cyclones. This is the reason why in 0 to 10 degrees you generally don't get a cyclone latitudinally. Then when you come to 10 to 30 degrees, will I get a inward vortex? And what do I call it as? Tropical vortex or tropical cyclone. The word is tropical cyclone. Okay, so the cyclones of 10 to 30 degree are called as tropical cyclone. Then in 30 to 60 degree, we call them as mid latitude cyclones. Mid latitude cyclones, also called as temperate cyclones. Temperate cyclones or frontal cyclones. ये तीनों एक ही चीज है. Frontal cyclone. So mid latitude cyclone, temperate cyclone, and frontal cyclone, they are same, found in the 30 to 60 degree. And subtropical cyclone भी इसी को बोलते हैं, the subtropical cyclone. Okay. Then when you come to 60 to 90 degree, do we have cyclonic conditions there? We have something similar to cyclones which we call as polar vortex. Polar vortex, which is a bad weather condition in that region, so we call it as polar vortex. ठीक है? So 3 cyclonic kind conditions are created in the 3 different regions. Tropical region, tropical cyclone, temperate region, temperate cyclone, polar region, polar vortex. वहां cyclone नहीं बोलते क्योंकि वो cyclone नहीं है exactly. ठीक है, वो vortex है, right? किस टाइप का vortex है, we'll see. Is this clear? ठीक है, so should we start with these? ये start करें? Very good. So which one do we start with? Let us start with the one which we'll spend least time on. तो इन सब में से सबसे कम टाइम आपको क्या लग रहा है, किस पे बिताने वाले हैं? पोलर वोर्टेक्स, क्योंकि अभी आपके पास कम टाइम है ना? तो हाँ जी, ट्रॉपिकल साइक्लोन. अच्छा, वो 0 to 10 वो तो बिल्कुल ही खत्म हो चुका है, उस पे भी टाइम बिताना है, जो है ही नहीं उस पे. हाँ नहीं, सबसे कम टाइम तो बिता चुके उस पे, हो गया. ठीक है, तब उस पे वापस नहीं आना है. ऐसा नहीं कि बस सर वो 0 to 10 वाला ही 10-15 मिनट करा के छोड़ दो. ओके, so let us come to polar vortex. Right, polar vortex. So polar vortex is a phenomena of polar region. Right, वो लिखते रहना है. It's a phenomena of the polar region. phenomena of the polar region taking place during polar winters and end of winters. Taking place during polar winter and end of winter. Okay. So now what happens in this is something that we have to draw. So please all of you draw with me. This is half the globe. This is equator. That's pole. Right? And this is like the 60-degree latitude. Alright. And then I'll draw the upper atmosphere. कौन सा जेट स्ट्रीम होता है इन द विंटर ओवर द पोल? पोलर. पूरा नाम चाहिए मुझे. पोलर नाइट जेट स्ट्रीम. So in the polar region we have the polar night jet stream, something like this. Can we say? कुछ ऐसा ही होगा ना? Something like this. It will go around the pole, right, in the upper atmosphere. इसीलिए वो थोड़ा सा गैप दिखाने का कोशिश किया है, right? So in the polar region you have a jet stream, something like this, what we call as polar night jet stream. Polar night jet. Clear? Okay, so please go on drawing with me and एक दो लाइन लिखना होगा वो साथ साथ लिख भी लेंगे, right? Because it's a simple concept, not too difficult. So the polar night jet stream which is flowing in this region is a west to east jet stream. West to east, ठीक है? And it keeps moving in the upper atmosphere during the polar winter. Starting from polar winter it moves. So you have to write that this polar night jet stream starting from polar winter, the polar night jet stream starting from polar winter moves in the upper atmosphere. Polar night jet stream starting from polar winter moves in upper atmosphere below tropopause in a west to east direction. Full stop. As it continues for nearly 6 months, it tends to trap the upper atmospheric winds or upper atmospheric air. Tends to trap the upper atmospheric air just below the tropopause. Tends to trap the upper atmospheric air just below the tropopause. And this air continues to cool. This air continues to cool over the winter. So which air are we talking of? The air in this region, यहाँ पे. Okay, all this air in the upper atmosphere gets trapped, something like this. Can you see that? Slightly grayish color. So that air gets trapped below the tropopause, and over a period, what happens to the temperature of this air? It becomes very cold. So hopefully this whole region air tends to become very cold. Okay, something like this. Where is all this happening? Just below the tropopause. So that air is trapped first of all by the moving air, so it does not allow the air to sink or go anywhere, it just holds it there. Okay, the cold air. Why is it not sinking below? Because at the pole also there is high density air. So below also there is high density air, above also it is high density air, so it goes on becoming stacked up and goes on becoming colder and colder. Okay, and the temperature of this in the tropopause might reach up to minus 75 degrees Celsius by the end of winter or somewhere by the middle of winter. Right? What was the average temperature of the tropopause? Minus 45. Yaad hai, over the pole. But this during winter might come down to minus 75 degrees Celsius. Okay, so this air temperature might come down to nearly minus 75 over the next 2-3 months. Why? Because it is trapped, so it remains there and goes on becoming colder and colder. Okay. So basically now what will happen is, please see. Have you written this temperature minus 75 degree? Then write down, because of this cloud formation starts here. Cloud formation starts here, which extends even above the tropopause. Cloud formation starts here, which extends even above the tropopause into the lower stratosphere. Extend above the tropopause into the lower stratosphere, forming the polar stratospheric clouds. Forming the polar stratospheric clouds. Above the tropopause in the lower stratosphere, forming the polar stratospheric clouds. Full stop. The upper surface of these clouds are frozen crystals. Upper surface of these clouds are frozen crystals, which go on to release chlorine radical. Go on to release chlorine radical in that region. Which go on to release chlorine radicals. Right? You have ions and radicals in chemistry. Okay? So it releases chlorine radicals in the atmosphere, which are highly reactive with ozone. And hence destroy the ozone layer. Highly reactive with ozone and hence destroy the ozone layer, creating the ozone holes over these polar regions. Creating the ozone hole over these polar regions. Okay, so do we understand how ozone holes are created? Right? First you get the polar stratospheric cloud. The top of them are extremely frozen crystal regions. They react and go on to release chlorine radicals, and the chlorine radical go on to destroy the ozone. Okay, so that's how the ozone depletion happens, to the extent of creating what you call as ozone hole in that region. When the thickness goes below 200 Dobson unit, we call it as a ozone hole. Right? That more of that you will do in your ecology. Now let us come back to what happens further. Then next paragraph. As the winters come to an end, around spring, somewhere around February, March period, as the winters come to an end around spring, what will start weakening? Because the winter is over. सबसे पहला क्या weaken होना start होगा? Yes, the polar night jet stream starts to weaken. Right? Around the spring, the polar night jet starts to weaken. Polar night jet starts to weaken. Okay. And Now when the polar night jet stream will start to weaken, what was it holding in that region? What is that air? Extremely cold. ठीक है? That extremely cold air held for those 6 months is what we call as polar vortex technically. This is what we call as polar vortex. Why? Because the air keeps moving in that region but does not go out and it just spirals there. Okay? So this air is what is technically called as polar vortex for those 5-6 months. Right? So what did we write? The polar night jet starts to weaken, full stop. Continue to write. For the winter 6 months, the cold air that was trapped within the jet stream, within the encircling jet stream, cold air that was trapped within the encircling jet stream, cold air that was trapped within the encircling jet stream was known as polar vortex technically. Was known as polar vortex technically. Full stop. As the polar night jet stream weakens, this cold air tend to spread to lower latitudes, within brackets subpolar region, lower latitude, subpolar region, and also to lower altitude, subpolar region, and also to lower altitude near the subpolar surface regions. Near the subpolar surface region. Also, these are extremely cold air. These are extremely cold air. Now moving over the subpolar region. And where do you find people in that region? Polar region or subpolar region? Where do people live? Subpolar. So the subpolar people will start experiencing what now? What will they start experiencing? Strong, extremely cold winds. They call that as polar vortex. Because that is happening due to weakening of the polar vortex. So they start calling this phenomena of experiencing the cold air as polar vortex. So this is the time, probably, you know, if you see in the last 1.5 months and all, in Europe, this year, last year, last to last year, every year in European region and North American region, Canada and all, you find, or Russian region, you find this news of polar vortex. When does it come? It starts coming somewhere by February. February, March is that period, and by March it will gradually end. Right, so what is happening? Starting from November, first the polar night jet stream is formed. That polar night jet stream will trap the cold air. When the winter is over, somewhere by, when the winter starts to come to an end and the polar night jet stream starts to come to an end, because now we are at 21st March ko kya tha? 21st, 22nd, we had the equinox. So after that equinox, now that pole is coming towards summer side or the day side. Okay, so polar night jet stream is over and hence all that cold air will descend, come to the subpolar region, and the people in the subpolar region will start feeling that cold air now. So they start calling it as the polar vortex phenomena. So that's exactly what you call as polar vortex. That's what we were writing. Okay, so can you just read me that last line? Let's crack it. आपका टी-शर्ट पे लिखा है इसीलिए मैंने बोला. हाँ जी बोलो. Subpolar region, which the people in the region, extremely cold air over the subpolar region, which the people in the region call as polar vortex. Call as polar vortex, which is a bad weather condition. Why? Because it is extremely cold. Polar vortex, which is a bad weather condition. in the subpolar region. Okay, so it can bring cold winds, it can also bring snowfall, because in that region there is a lot of snow crystals which are there. So all of them will gradually descend, and hence it also brings snowfall, heavy snowfall, and all this will happen. So with that we come to the end of polar vortex just in time, है ना? So 3-4 मिनट ही एक्स्ट्रा लगा, ज्यादा समय नहीं लगा आप लोगों का. So what is next? Polar vortex के बाद temperate cyclone. Next class we start with temperate cyclone, but before temperate cyclone you have to do air masses, right? So please read your air masses from NCERT and then read temperate cyclone from NCERT and then come to the class. That will help. Okay, and after that we'll do tropical cyclone and then we'll do monsoon. That is the sequence. So please read in that sequence and come. For monsoon you can also refer India Physical Environment NCERT climate chapter. ठीक है, क्लाइमेट चैप्टर ऑफ इंडिया फिजिकल एनवायरनमेंट. आई नो बहुत मुश्किल है इतना पढ़ पाना, आईएएस का तैयारी में समय नहीं मिलता है, कोशिश कर लो फिर भी. ठीक है सर, एनी मेजर डाउट यू वांट मी टू टेक अप? नथिंग, दैट्स इट. थैंक यू. द वंस हु हैव डाउट कैन कम, द रेस्ट ऑफ यू कैन गो. थैंक यू.